Welcome to 56-Bit Cloud Cafe, your go-to destination for all tech topics in the cloud. I'm Athir Zalat.
And I'm Patrick Camilleri. And together we'll be addressing various cloud topics.
Hello everyone, and welcome back to our series on DynamoDB. In this episode, we will explore the intricacies of data modeling and table design. Now, understanding how to structure your data is crucial for optimizing performance and ensuring scalability. So let's dive in. You've covered the basics of DynamoDB well, but let's dive a bit deeper into how it is structured. What are the fundamental components of DynamoDB table?
So yes, Atir, the fundamental components of any DynamoDB table are mostly the table itself. So that is the highest hierarchical level that you have. There is no database concept here. The highest level is a table. A table is a regional component. It is situated in a specific geographical region inside AWS. And it's the core unit which stores your data. Each table holds items that you want to save with a specific structure that you set. Now that is another word that I have mentioned, which is the word items. Items is the technical word used for the actual data entries inside the table. So each data entry, each part, not part of the data, but rather each kind of row, if you want to see it from a relational database point of view, that is known as an item. And then inside each item, you might have pieces of data. This is known as an attribute. So an attribute would be things like the name, the product ID, the creation date, whatever it is. Each attribute can have a type, and it is very flexible. You can change these things around. So tables, items, and attributes. Those are the main fundamental components of a DynamoDB table.
Primary keys play a crucial role in any database. Can you walk us through the DynamoDB context? How do primary keys work in DynamoDB, and what are the differences between partition keys and sort keys?
Primary keys are an essential component in both SQL and NoSQL databases. They are keys, so they are unique, and the reason that they exist is to find the actual data you want to find. Because NoSQL databases are key value stores, the key is this primary key. So a unique code which allows you to retrieve a piece of data, and it also allows you to show the NoSQL database, the DynamoDB table, where the data is. So what happens under the hood is that all your data, whether you have a few megabytes or whether you have thousands of terabytes, that data in a table is split into pieces known as partitions. And each partition has a unique code allowing us to know where the data is, on which server, and in which partition. So these primary keys are known as partition keys as well, and it allows efficient scaling and querying accordingly. Now, inside every partition, you might want to go deeper to get a specific piece of data, a specific item. And to do that, you would need as well a sort key. So here, the primary key will be made up of the partition key and the sort key. So when they are together like this, they are known as composite keys. The sort key allows you to further drill down into the data coming from the partition key data. So yeah, primary keys, partition keys, sort keys, all are very important. You might not want to use them all, but depending on your design, they are extremely important to find your data in a speedy and efficient manner in DynamoDB.
Okay, perfect. Now, indexing is always an important topic when it comes to databases. I'm curious on how DynamoDB handles this. Can you explain the concept of secondary indexes and when to use them?
So secondary indexes allow you to query data using attributes that are not your primary key. So if you're looking for your data through a primary key, say the creation date, you can, using a secondary index, you can query the data based, even if you don't know that primary key, right? So something else like update date instead of creation date. So this allows you to query data other than with your primary key. Now, please keep in mind that in DynamoDB, there are two types of secondary indexes. There is a global secondary index. This has the advantage of allowing you to completely change your primary key, just like the example I gave, where we used a different primary key, and you can retrieve your data with both the main primary key or the secondary index primary key. That's the advantage. The disadvantage is that DynamoDB will hold a copy of your data or a copy of a piece of your data to allow it to do this behind the scenes. So your costs might go up here. On the other hand, there are also local secondary indexes. These do not have the same cost issues because they are saved with the main data, but they have limitations. Limitations like you can only create them when creating the table. You can't create them later. Or you can't change the primary key. You can only change the sort key with a local secondary index. So local secondary indexes are cheaper, but much more limited. Global secondary indexes allow you to do whatever you want, but more expensive. And both have a use case, and both should be considered when using secondary indexes with DynamoDB.
Now, from what I know, developers always want to design databases efficiently from the start. What are some best practices for designing efficient and scalable tables in DynamoDB?
Best practices come in many forms, and you might even evolve your own best practices as you get more in tune with this technology. But there are obviously some best practices that are worth mentioning. And the first one would be to define access patterns, to define how you will be reading the data. So how will you retrieve that data? Is it going to be using a specific thing like creation date or something else like name or surname or both, right? So what I'm deciding there is how I'm going to be accessing the data. That's the access pattern. And by deciding before going ahead and creating tables and secondary indexes, that allows you to have a more efficient optimal structure, especially when it comes to those primary keys. You can still change this. In fact, another best practice would be to start simple. Just start with a basic structure and change and adapt your application as required. DynamoDB is very flexible, but yes, of course, knowing beforehand certain patterns and certain ways that you will be evolving your data structure definitely helps. There's also a level of normalization that you can use. Normalization is an important an important concept in databases, where a complex piece of data is split into smaller, more manageable tasks. And you can still do this in DynamoDB. You can split your data into different tables if you wish, but you might want to also balance that out, that sometimes that can have an opposite effect as well.
One of the biggest challenges with NoSQL databases is handling relational data. How can you handle relational data and complex queries in a NoSQL environment like DynamoDB?
So when you have complex queries, one thing I would suggest is to actually go against the first best practice that we mentioned, where there is normalization. As we said, normalization is splitting up your complex data structure into multiple pieces, multiple tables if need be. That's fine, but sometimes you want to find a balance there and go the opposite way. This is known as denormalization, where you want to store some redundant data, so data multiple times, to avoid having to do joins across multiple tables. So it depends a lot on your use case and on the design you wish to achieve. Sometimes you might want to store all your data in a specific item, so you can have a key and a value. The value would be a whole item related to your query. So here would be, for example, a user, right? All the user data is in a JSON format for each item. And that allows very simple queries without requiring any joins and any complex querying done on the database. Finally, DynamoDB has features like DynamoDB streams, which allow you to capture changes to the data, and you can then react to those changes. You can, for example, launch Lambda functions based on the updates or the deletes that are coming from the database, from the DynamoDB table. And this allows you to do real-time processing and analytics as well. So complex queries can obviously be quite difficult to design, but there are many ways of doing this, and definitely DynamoDB has a lot of features to help you there.
And that's it for our discussion on data modeling and table design in DynamoDB for today. Join us next time as we delve into querying and scanning your data in DynamoDB. Until then, happy cloud computing!
If you have questions, suggestions, or want to share your feedback, connect with us on social media.
Also, don't forget to subscribe to our podcast and to leave us a review to help others find their way to the Cloud Cafe.